All right, hello and welcome back. My name is Cameron Kirk and I am a software developer, and this is my series on DE10 Nano projects. And in today's video, we are doing another walkthrough on this wonderful DE10 Nano repository by Zhangman. Good news is I was able to get some of my pull requests approved, so now the docs are in the wiki, or sorry, they're no longer in the wiki, and now they are on, well, anyways. We are going to be setting up the development environment. Let's jump right into it. So for this one, this is going to be sort of like my spin on this setup. They're asking you to set up a Debian operating system as the cross-compiler development environment. In this case, I'm just going to be using Windows 10. For the most part, all we really need is to have Quartus Prime installed, and of course that is the free version, Quartus Prime Lite. I'm using version 17, as you can see here. The guide uses version 20.1, but I was able to get everything working using version 17, so I don't think there is too much of a difference between these two versions. So once you get that installed, and I did cover this in a previous video in my Verilog development tutorial series, that is where I show how to set up Quartus and get everything going so that you can flash just the FPGA device, right on the board from the JTAG port on the other side. That's the USB port that is on the same side as the power port. So the reason for this guide is I came across something coming up next on actually writing your first embedded Linux program where you are controlling the FPGA from the HPS, or the hard processor system. I always keep forgetting what HPS. It's a microcontroller. I don't know why they call it HPS. But anyways, in order to do that, I'll give you sort of a sneak peek of what that looks like. In order to do that, so this is on the next guide coming out, building the SOC design. You are going to need to use a tool that generates this header file, and I'll let you look at this header file. So this was generated from a script that I am only able to I only seem to be able to get this working in a Linux environment. I don't know how many hours I've dumped into trying to get it to work with, MinGW. I hate MinGW, but screwing around with that on Windows, I was like, look, we have Windows Subsystem for Linux. Check this out. We have Ubuntu right here. I want it working on this. And so that's what we're going to set up today. Now, I used to have our image, the SD card image and everything we did for those videos. I used to have that on my Ubuntu disk. I wiped the whole thing out, and I am planning on redoing it because I want to turn on change tracking with GitHub. And the purpose for that is also for another video further down the road. We are going to start experimenting and changing kernel code and having change tracking for that image that you're developing, that, that custom operating system that you are making is important. But anyways, that's all aside. What we're going to do is I am going to go and I am going to uninstall. Let me get the face cam out of the way. I am going to uninstall Ubuntu, and this does wipe out your file system. So the reason I am doing this is, do not follow along with me unless if you really want to. The reason I am doing this is because I want to cover this for someone who has absolutely nothing and they've never used Ubuntu before on Windows Subsystem for Linux, WSL. I want to start from scratch. And again, this is where change tracking comes into play. If you're not using change tracking, then you are going to be fearful of deleting your whole file system like that, like I just did. But if you're using change tracking on GitHub and all of your code and all of your files are on GitHub, And you're, even if it's in a private repository, which I know isn't necessarily private, GitHub does still have access to it on their servers. You should not be fearful of losing your whole file system. I'm just now realizing this. Like, you should really think of this Ubuntu app as just like any other microcontroller. You don't necessarily want to keep your critical code on there. You know, you don't want to like actually have that as your primary backup running on the operating system, because as we all know, like, you know, running off of a little flash SD card right here, these things get corrupted at the drop of the hat, or, you know, anything can happen. You can just lose everything. So you need to set up your development environment like you would for a board, where it's like you're not going to be afraid if the whole thing gets wiped out. So anyways, let's get this installed, and I am going to pause the recording until this completes. So I will be right back. Okay, we are back, and that did not take long for me at all. Let's go ahead and open this. And yeah, I don't think it goes. It depends on your system how long this takes. While that is cooking, let's take a look at our guide here. So again, in order to get my setup for how I am getting these other things done, in order to get my cross-compiler development environment, I'm going to be using Quartus for Windows. So I have Quartus ready to go. One of the things that I came across is I actually 100%ed this guide, but tried to load it on Windows Subsystem for Linux, because they're loading theirs on Debian. And just a brief note, you could totally get a Debian app if you prefer that. Now the catch is, man, I'm getting distracted. Let me turn the camera over here. The catch is when you plug your USB JTAG into this board. I'm trying to think of how to word this. Windows Subsystem for Linux does not see the USB device. It doesn't actually detect that it got plugged in. So with that and then I did some Googling. It's probably in a tab that's still open. Yeah, lucky me. This guy was trying to plug in a USB webcam, and then somebody said, I don't know. Somebody said that basically it is not supported on WSL 2. Does not have any, I don't know if that's the reason. But when you're using WSL on Windows 10, it cannot access USB devices. And apparently, I am just going to create my user. Apparently, if you use WSL, you do this on Windows 11, they do have USB support. But I have not tested that, so I am not going to promise you anything there. Okay, we are going to do a sudo apt-get update and authenticate. Okay, so we need to download Quartus Prime. I'm not sure how much of this is completely necessary, but when I did it on my own, I got all of this, and so let's go ahead and get all of this again. One thing I do want to point out is we're not going to be using Quartus Prime inside Windows Subsystem for Linux to JTAG program our board, because apparently Windows Subsystem for Linux does not support USB devices on Windows 10 and on the version I'm using. If you plug in the board, this can't detect it, so you can't flash the FPGA from here or do anything like that. But that's okay. We're going to be doing that from the Windows version of Quartus. I have Quartus installed over here. So anyways, we need to go to the FPGA Software Download Center, and I am going to clear all my results. Link is in the description, and it will look something like this when you get here. And the first thing we need to get is the latest version of Quartus Prime Lite Edition. So I'm going to use 20.1 for Linux. And I clicked this, and I got the complete latest version. 21.1.1. Now I already have this downloaded, so this is going to be in my DE10 downloads. I have a folder in here called Linux env, and there it is. That's what I'm using. Okay, and then the other thing, so you're going to scroll down here. You're going to, not this one. You want to get individual files and get Quartus Lite set up. Hit this one. Don't get Questa, and get Cyclone 5 device support. We do want that. Okay, so get those two downloaded. I already have them downloaded, so I'm not going to click it. And then the other thing you need to do is back over here. This one is tricky to find, but I'm going to show you how to do it, at least at the time of recording this. Click on Quartus, and then click on Standard Edition. And then get 20.1. And get Standard Edition 20. Oh wait, Intel SOC FPGA Embedded Development Suite Standard Edition software version 20.1 for Linux. That's what you need to download. And I already have it downloaded right here. So go ahead and get all these downloaded. And once you have them downloaded, we need to get them copied into our Linux environment. So I'm going to make a directory called downloads. Then I am going to cp-r from the mount folder, C, users, case sensitive is important here, documents. I am just typing the first few letters and then hitting tab to autocomplete. Going into my DE10-Nano folder, and I'm going to downloads, and then I am going to get my Linux env, and I'm going to copy that to my downloads folder here. So push enter, and that is a lot of data, so it might take a moment to make that transfer. I guess I'm going to pause the recording while this loads. Okay, we are back, so moving right along here. If we go inside the downloads folder, we now have our Linux folder in here, Linux environment folder. And the first one we need to run is the Quartus Lite setup. So back over on the guide here, you get that downloaded, looks good. Have this good. We're going to run 20.1. Now we have 21.1.1, but that's going to be fine. The latest worked for me. We're going to use the latest here. Hit enter. And hit enter. Hold down the enter key to go through the license agreement. Reply yes. All right, installation path, we can leave that default. We're gonna have to change it on the next one, but on this one, we'll leave that default. Hit enter. And yes, we want Quartus Lite edition free. Devices, yes. Cyclone 5, yes. It auto detects whatever device file you have in your folder. Get that, and then we'll say yes. And this might take a moment, so I'm going to pause the recording and let this load. Okay, we are back and it is done. We are not going to create a desktop shortcut because we are not accessing a desktop from here. We're not going to launch it either, say no to that. We're not going to provide feedback, say no to that. Great. Now we are going to run clear ls. We're going to run the SOC installer with a catch. We have to change the install path to be the same as Quartus. And I know that these are different. One is from standard, the other one is light, but it works. So don't worry about it. Push enter, hold down enter, agree to the license. Yes. Okay, now this is where we must change it. We want to do home home. Oh, good. Kirk C1 slash Intel FPGA. Oh goodness. Underscore light slash 21.1. And before pushing enter, here's what I'm gonna do. I'm gonna open another Ubuntu. Oh, come on. I'm gonna open another Ubuntu. Okay, LS. Okay, Intel FPGA Lite. So in there, LS CDN 2021.1 LS and PWD. We want this path. So Intel FPGA underscore Lite capitalization counts Intel FPGA Lite LITE slash 21. I believe we are good. Okay, so we're going to close this extra terminal and we will push enter on this one. Install the programmer tools. I'm going to say yes. I don't know what is absolutely necessary for what we're going to be using this for, but let's go ahead and get everything. And yes, the function is correct. And we are going to let this install as well. I am going to pause the recording. We will come back when this is done. All right, we're back and that finished. So now that we have these guys installed, we are going to start configuring our .bash underscore aliases. This is sort of a script that you can put together that is hidden. So hold on a second. Let me get back to the home folder. It has to be in your home folder. So pwd got to be in your home and then your user folder for it to work. But basically, it's sort of like having a .profile configured. Anyways, if I do an ls, you'll see that it's not here. But if I do an ls-al, you'll see that it is still not here. But once you create it and you start putting things in there, those are things that are going to be used every time you log on. So, yeah. Let's go ahead and do that. Now, one thing to note is, well, I don't know. I think I'm just thinking about too many things at the same time. All right, we're gonna do code space dot bash aliases. It's gonna get Visual Studio Code configured for us and open up that file. Even though it doesn't exist, it will open it and create it for us. And we can put in what we want to put in. The commands on the guide here are using the echo command to get the text into the file, using the redirection there. I am not going to do it that way. I am just going to, I saved the one I used earlier, so I'm just going to copy and paste what I used from earlier and paste it in there. So paste. Save. So this is pretty much the same as what we saw in the guide, except we need to change a couple of things. If I look in here, I have Intel FPGA underscore Lite, Intel FPGA underscore Lite, but now the guide uses 20.1 and we're using 21.1. So as you can see here, that needs to change. Okay, so save that and we can close out of this. The alternative is you can copy this text, copy it and paste it into your bash, copy this text and paste it into your bash, or you can just copy all these commands and run these commands. Since we can't actually connect to USB devices, we're going to not worry about JTAG as a normal user. We can skip through that. We are going to create a working directory, but I am not going to do this export command, and I am not going to put that in my .bash aliases file. So let's go ahead and make that working directory. In our home folder, we're going to do make dir, what is it, DE10-Nano, what is it? Nano-WD. ls. So that's going to be a spot for us to put code. next time. Okay, the ARM compiler. I am not going to do what they used for their ARM compiler, but we do need a ARM Linux GNU ABIHF. I am going to put this link in the description. I have shown it once before in a previous video. This gets you the ARM9 toolchain. And what you want to copy is this second one right here. If you copy that command, paste it into here. I get that copied. Copy. So right click is how I'm pasting. Give me your password. And off it goes. Say yes. It's installed. Yeah. The other important thing, which we already took care of, is this cross-compile variable. We're setting it equal to arm-linux-abi dash. What did they have? Or should be copy. All right, I know I'm jumping around. Be like that actually. Let's go in there. Let's go in there and fix that. I'm just going to jump back into code .bash aliases and fix that. I don't know what the differences are between different ARM for ABIHF versus. We're missing the HF difference. I don't know what that does, but go ahead and make that change. Paste it in there. All right, close that down. So we have this done. And then that last one that you saw, this one right here, the Arch ARM, we may or may not need that. I got that off of the Stack Overflow answer. They do these two exports. I'm just doing it just in case. I don't know if I necessarily need that or not, but I'm going to keep it. Okay, and that is all we need to do. So to check if this is working, if you type, we need to exit, and then we need to start Ubuntu again. Okay, so if I type embedded, we get that autocomplete embedded command shell. I'm going to push enter to run it. Where did we go wrong? Okay, give me a second here. I'm going to pause it. All right, so I think I screwed something up in my. I can't ls anymore. I looked it up on Google, and I think it's because I screwed something up in my .bash _ alias. So if I do an ls, if I do a bin / ls -al, this guy right here, I think something got messed up. So I am going to do a bin / rm .bash aliases _ aliases, enter, run that again. Gone. Start it up again. ls. Okay, we're back. So I guess I screwed something up. So yeah, I'm glad. I was just about to wrap things up. We don't want to do this. We do. Let's do the first one. So I'll copy this command sequence, paste it in here, and push enter. Then what I'm gonna do is I'm gonna go. Let's do Vim. Maybe using Visual Studio Code screwed something up. Okay. So here's Vim. I'm using the arrow keys to move around here, and of course we want to switch this to. We're gonna do I for insert mode. we're going to do 1, hit the delete key. We're going to do 1, hit the delete key. And push, don't push enter. We're going to hit escape and then :WQ. So write that. Well, let's just do W. Now what we're going to do is we're going to go to the end here, hit insert, make some new lines. I know for a fact I want these in here, and maybe it's complaining. Oops. Delete this out. Let's do insert. Oh, I'm already in insert. Right click, paste, and then maybe it's complaining that I did this HF thing. Let's take that off, because I didn't have that originally, so let's just take it off. All right, hit escape, :WQ, and then type exit, and hopefully we didn't fry everything. Whew. Okay, so we're good. So if I type EM for embedded, if I double tap tab, it's going to give suggestions here. And this is how we know we're doing good. We have this embedded command shell, but that's not all we need to check. So let's go ahead and run that embedded command shell. Why can't I get the... Oh. Sorry if that's really loud. To turn down the volume. Sorry about that. All right, command shell. There we go. Enter. That's a good sign. Now what we really want to know is, can we run... Yes, this is what we're looking for. So once you see that you have this command right here, the SOPC create header files, I think I can do a -- help. Yeah. Once you see that this is running, this is everything we need for our next video. And you know what? While we are here, I want to go ahead and fix this problem, and you should definitely follow along with me. So they're saying in here, at this file path, there's an error, and the error is that is not found. So here's how we're going to fix that. And we need this for the next video, and I will mention this in the next video as well. Let's go ahead and knock this out right now. We're going to go into our Intel FPGA Lite folder, and we're going to go into our 21 folder. So I'm just typing 21 and hitting tab for that autocomplete, by the way. And then we're going to go into Quartus. Then we're going to go into SOPC Builder. We're going to go into the binary, and we're going to go into the We're just going to go right here, ls. And then there is create header files. We're going to go into Vim on that SOPC create header files. We're going to go into Vim on that. Okay. And I read through this, and I was able to get this working simply by deleting this line where my cursor is. So I'm going to do a $D $, and that will delete that line. And then I'm just going to get rid of the blank line as well. Okay, so hit escape, :WQ. That will write to that file. And so now when you run... All right, let's go back to the home folder. Now when you run the SOPC help, we don't have that problem anymore. Now it's giving us actually the full help. So it is not complaining anymore like it did before about something .exe not being found. Yeah, it's not really important getting into why you have to change that. Well, yeah, I'll tell you why. So we're in Windows Subsystem for Linux. And for some reason, when you look inside the script with a text editor, for some reason the person who wrote this script at Intel or Altera seems to think that even though we're running in Windows Subsystem for Linux, you still need to end everything with a .exe, and this is not true. We installed the Linux version of Quartus, and so we are not ending our executable binaries with .exe. So by simply removing that variable of assigning it, it'll run it without the .exe, and it'll work. All right, I hope you enjoyed this video. That's all I got for this one, and I will see you in the next one. Take care. Bye-bye.